the agenda about today, a short word to EVT, and then a short intro to the EyeVision software for all who don't know our software, to have a short intro. I can really recommend, we have captured all the other webinars, and to have a look to the intros about EVT, basic knowledge about installation of the hardware and the internal structure. So I have today only a very brief intro. And if it's too less, I really recommend to have a look to our YouTube channel, or better to our newly invented Academy. It's on our webpage. You are very prominent. You will find it. I think you have also a link to this Academy, where you can see, where you will find also these dedicated small videos about the installation of the software, all the projects and everything. If there is something unclear, but you're welcome to ask today at any point. So this would be the first step. Then we will have a short look to the tools of deep learning. I think this will do also Ms. Booker, and then we will have a look how to use the deep learning tools, and also the models which we already have, and how to use transfer learning in EyeVision. A short glance at the hardware on which the EyeVision software, of course, the EyeVision software runs, but also the deep learning system, and especially also the accelerators like a GPU, or more interesting, I think, is the Coral chip or FPGA, as long as it's available. And of course, then some real world examples based on different projects we have already stored in the web. You can download them and simply test it after we finished. And about some new developments at the end, about skeletation, auto annotation, data augmentation, and all of this. So about EVT and our products. So we are located in Germany, in Karlsruhe. This is our headquarters. We have a subsidiary in Seoul, Korea. So we handle all our Asian marketing questions and support from Korea. And for the rest of the world, the headquarters is Germany. And yes, and we have, as you can see, different distributors around the world, so that you can get support nearly everywhere. Of course, there are a wide area of white spots, but we are working to make this better. We are in the center of Karlsruhe, very easy to arrive. We are airport or train station. We are founded in 1999. We have 21 staff members, 8 in sales and 9 in sales support. And we have in the second division 12 developers. We do direct sales for OEM customers from either Karlsruhe or from Korea. And of course, we have distributors and integrators, which does the integration of our software at the end customer side. We have a key product, or our USP is the EyeVision software. This is whatever you hear today, and also in all the other webinars. EyeVision is our key product, and whatever you are doing, you use EyeVision. This makes it easier for you, because you don't have different products. You have exactly always the same product. If you run it on a PC, embedded platform, or smart sensor. And of course, we have all the tools inside of the EyeVision software for 1D line scan or whatever applications, or 2D in gray and color, or in thermal machine vision or hyperspectral, or of course 3D. And because deep learning is a major or a clamp around all of this, deep learning can be used with most of all of these data types. I think today we should not talk about 2D image processing, more about data types, but the majority of all the users think in 2D, mainly in gray and color imaging, and all the other imaging images like thermal or 3D or hyperspectral is anyway difficult to understand and explain for the majority of the users. So we will still use the standard terms. And what we also do is we do some specialized hardware developments, especially for light and lens camera processing. And therefore we have also our specialized hardware for deep learning in embedded systems. Of course, we support the standard CPU and GPUs, but we also support Coral. So Coral is a specialized chip made by Google, and this enables even ARM-based systems or also PC-based systems to run deep learning very fast on also low-powered CPU environments. We also support FPGAs, so that's why we have these hardware which enables us to manufacture, for example, special sensors. And about the EyeVision software, to handle it easily to the customer, we made these different products, which as you can see on the left side, it's always EyeVision, and the difference is only the instruction set, so that it's easier to start. For example, if you want to do 3D, you don't have to search for the 3D tools. You could use, for example, the EyeVision 3D area. And because the deep learning is in all areas available, you can add this to all of these packages. Anyway, you can add each comment from the EyeVision to each package to generate a special package which fits to your needs. So this is a short overview about the different hardware platforms, only a rough overview. So for the types of platforms like the vision sensors, the smart cameras, embedded systems, and the PC systems with all these interfaces like USB, FireWire, GIGI, Coax, Camalink, CoaXPress, GeniCam. It's GIGI includes GeniCam GenTL, which we have as our own transport layer and consumer, so we can communicate with all GIGI cameras. But we also support all the native drivers from the majority of all camera manufacturers. Right now, the software is available in German, English, French, Spanish, Turkish, Chinese, Mandarin, Korean, and Japanese. This one language I would eliminate in the future. I think you don't need it. So our markets, yes, everywhere where you can use the machine vision. And yes, that's a short overview where we are working. And let's have a shorter look to a detailed look to the software. Yes, we discussed this already. I think Ms. Buka will show you this in more detail. And what can I tell you for the moment? We will, yes. Anyway, I explained all this stuff about the acceleration tools. So right now we support the Coral chip from Google. maybe if you saw older presentations 2 years ago, we started with the chip from Intel, the Myriad platform, but due to considerations of Intel or the availability of the chip, we had to change about a year ago in our development and do a redesign of our boards. And now we support the Coral chip from Google. It's anyway at least as powerful as the Intel chip, and but the power consumption is outstanding good to build small embedded systems based on, for example, the Raspberry Pi board. So if you use a standard Raspberry Pi, you could use the Coral USB stick, and we made Compute Model 4 board, which includes also Coral, 2 Coral chips, to give these embedded platforms enough power to do deep learning. And yes, what to say? Yes, I think this is part of this when I hand it over to Ms. Buka. I already explained this here, so there's nothing more what I can tell you for the moment. I can, of course, start the software. So everybody should have, after with the invitation to this webinar, a download link for the EyeVision software, and so you can download this version and simply install it. The download link fits to Windows. If someone would like to use Linux, you will see the rest of the presentation in Linux. You simply can contact us then with your Linux distribution and your target platform like x86 and Ubuntu, or like Raspberry Pi and Raspbian, I think so. You send us the target platform and we send you the download link for that platform. Generally, we deliver the download link for Windows. And yes, you can run it also on with Windows 11. This year is Windows 10. After you have downloaded it, installed, the first step is, of course, you have to select the hardware which you want to use. In this, therefore, we have this hardware configurator in the software, which enables you to select your capture device from the list. So that means if you don't have one of these manufacturers, you could use, even if you want to capture gray or color images, the direct show on Windows, or video for Linux on Linux. And then you can use all the USB cameras. If you have any camera with FireWire, you could use this driver, or if you have any camera based on the GIGAI interface, you could use these 2 interfaces. And of course, you can use also, this is something which I always forget, if you don't have any of these, but you have maybe a scanner, you could also use the Train interface, which is part of the software, to capture images directly from the from a Train scanner. I'm just looking for the Train, but it's here anywhere. Yes, so there shouldn't be any problem to capture images. If you don't have any camera, that doesn't matter. You can download our our project files also for deep learning, 3D, 2D, and thermal and hyperspectral. All these projects have already captured images, so that you can work on these images. First of all, you see the solution on the images, and you can work with this solution directly. And now I know also why I didn't found the Train driver. I already have activated it here. So you simply select the driver you want to use, and as I did it with Direct Show, you simply select, you mark it here and you select it, and then it's here. And if you don't need it again, you use it, you unselect it. So you, as an answer, yes, you can use multiple drivers from multiple hardware manufacturers to capture images from different devices. Okay, so after you have done this, after the installation, you simply can start the EyeVision software. You have a support version. If you want to do it, you can sign up for our developers program. Then you have also the option to get the nightly builds, and you are always at the edge of our development. But of course, then with the nightly builds, you might have some minor bugs inside because it's nightly and not the final release, which we distribute. A few important things which I want really to mention, because it makes it much easier to understand how the software works and also to test the software. So we have this project feature in the EyeVision software. This is really nice because it's very fast to see how the software works. So if we select one project now, let's say we try to have any 3D stuff for bin picking. I open up the deep learning, but you will see a lot of deep learning. So that's why I use now a different one. And then as you can see here, immediately it loads up a kind of user interface. It depends on the customer, how nice it is and how it looks like. I can show you also another one, only to give you an imagination how the user interface could be. And there are a lot of other options. And as you can see, if we have here a point cloud, and if I run it again, you will see with the next run we have another point cloud with also the segmentation and detection of the parts. And so that's why I said you can, if you don't have a camera, that doesn't matter, because we have stored a lot of images in these projects. And if you, for example, open up this one of the tools which have needs to load something, you will see it opens up exactly the projects which we have selected. You see it on the left top. And then it goes to imaging, bin picking, and we see all the images which belong to this. And each time the tool is running, it loads the next image, so that you can really simulate a camera operation, so that you are very close to a real camera. And of course, you can see how we did it. And that's the idea behind of it. We made these solutions that you see, first of all, the different how the images looks like, but also how we did it. And so if you run through this, you will see immediately, for example, now the next image with the different orientation of the parts and how we found it. The boxes on top in this case are the air field above the parts to pick it with the robot. So you see, we find a lot of these parts, but first of all, we cannot pick all with this robot, and some of them cannot be picked because there is not enough space, for what reason ever, based on the definition of the minimum space to pick it with the gripper for this. So maybe one other project which has a little bit more complicated user interface, so you don't have to see always the program editor. Now you see here any background, and you can start it, stop it. It could also be automatically done. Here you see an output. This is here because we are in the demo mode. So this is one of the only restrictions from the demo mode. that the communication with other systems is limited. All the machine vision stuff is working, but if you communicate to a machine or to other systems, not all the communication is done. In this case, one of the image transfers is not done. So this is mostly a restriction if you have 100% inspection anywhere. Beside the countdown, so you have 90 minutes, then you can save everything and you have to restart with the demo mode. But all the other stuff is still working. And here you can see, for example, of course, we don't have a menu and nothing. You have different buttons for different actions. You could add behind each button user access control with password and everything, which I didn't activate it here for the demonstration. Or you can do, for example, here, this kind of application. You have this user interface, you have the sliders and all this other stuff. I don't know why I can't start it. So you can go to the integration, then you have this user interface. I only wanted to show you the user interface and of course also the slider and the other stuff in action. But with this latest not supported version, it's not working. With your version, because we only send out for all the customers the release versions, it's working. I know it's working because I presented it really often, but for the moment it's not working. So we see here how the software is running, how the tools are working, and you have here the single step operations and see exactly some communication. You have a script interpreter. All these details can be seen in our Academy on the YouTube channel in different videos, which explain exactly what you can do with the script interpreter. So there's not so much inside. You see it's a Visual Basic compatible syntax. There's not so much here inside, but you have full access to all the tools, to all the tool parameters, and you can change the parameters from each tool based on the script interpreter, which allows you simply to access and change everything. So this is a short intro to the EyeVision software. Of course, we have the inter-tool communication, but this so with different options like registers, maybe you see it later in the presentation of the deep learning. So here you see, for example, the results of the different tools if you go through, and so that you have an overview which tool generates which result and how to access it. But I really recommend these other webinars which explain it in more detail and very lengthy. And also in the Academy we have short videos which exactly handle only, for example, how to use the registers, not only the value registers, also the other registers, or how to use the script interpreter, how to access from the script interpreter the different tools, or how to use the built-in web server of the software to control your EyeVision program from anywhere. If you're on the same system, you can use the local loop address, and of course you have to know point one. You have to know which port you select. You can decide which port you use. Normally we use the 127 and now the 8080 port, but it's a configuration in the EyeVision software. And here you see now, if you don't have a problem with this version, yeah, it's working. You see here, you can control the EyeVision software and everything from wherever you have access via the web, as long as you have opened up the software to the web access. Of course, with no web access, no web server is working. Yes, this is a short intro into the EyeVision software. I hope you got a short glance. If you do by yourself some tests, I always recommend to make your own project. Because it's very easy, you simply give the project a name, like my project, and then you start with an empty project. There are, of course, no programs inside because you didn't have saved the program, and there are no images and nothing, but all the stuff which you are doing is in one place, so that it's not spread it over all the other projects. Or if you want to change one of our projects, maybe you simply make a copy of it and work in that project, so that you have always the original. Of course, you can download it from our web server if you need it, if you modified it. If you want to know where the projects are, on Windows it's easy. For Linux, of course, depending on the distribution, it's a little bit different. So that's why we built in these on the file, the show data directory. If you call this, you immediately are in the data section of the EyeVision software, and there you find the projects, and here you will see also the projects. So as you see, I use always the same name. Here my project from today, and here you see we have all the stuff inside. If you want to have your own bitmap in your for your application, you simply copy here bitmap or PNG file, and based on the webinar how to make a GUI, you then simply can select, for example, one of these images to make your nice user interface with all the buttons and everything you saw in the WebGear solution, which unfortunately not worked so well with my current version. So this is what I wanted to show you for today as an intro into the EyeVision software. If you have some questions, then you could ask me now, else I would hand it over to Miss Buka, and she will give you an intro to all the details about deep learning, and show you also some deep learning stuff on her computer with the EyeVision software.
Okay, so I will share my screen. Yes, so as mentioned, I will give you an overview about deep learning in EyeVision. First of all, I would just like to tell you what's the difference between using classical image processing and deep learning. If we use classical image processing, we often have to use different tools like filters, and we have to build the whole pipeline. We have to adjust parameters, and often sometimes when we have problematic images, these results might not be so robust due to noise. So then we can introduce deep learning, we actually do everything with a model, deep learning model. There you have already this kind of filters that was in classical image processing, but it's just with this model that you can directly apply to your images, and the results are also more robust to noise. Normally, when you create a deep learning model, you have to prepare data, often big data sets. You have to label them, but there's also a variant of deep learning called transfer learning, when you use a pre-trained model that already learned good features of your images, and then you can actually use less images to adjust the model to your use case, and also it makes the training faster. Just basic about deep learning. In computer vision, we normally use convolution neural networks that consist of a set of convolution layers. These layers are responsible for actually applying sort of filters that after training can deliver good results with the images. In order to prepare a model, we have to, as I said, prepare a data set, label the images, then we get the model, and with new images, we can apply this model and get the desired output. What kind of outputs can we get? So we have different tasks in deep learning, starting from the basic one, which is image classification. It gives us the output, we just get the information what is in the image, but with additional feature heat map, we can also see the focus of the network on the image while doing the prediction. So it already gives us a weak localization of the detected objects. Then if we want to more closely localize the objects or multiple objects in the image, we use object detection. And if we want to get a exact form of the each object, we use image segmentation technique. In the EyeVision, we have so far the tools to execute this kind of models for image classification with the feature of the heat map, object detection, image segmentation, but also optical character recognition. We have also some of these plugins in the light version. What is light version? These are the plugins that we normally use when we have weaker hardware like Raspberry Pi, because while executing a model, we sometimes need, we do it on CPU, but with weaker hardware, it can take much more time. So we use a quantized, optimized variant of this in form of light deep learning models. We also have a tool to annotate images for image classification or object detection or segmentation, and also a training graphical user interface for training image classification model. A little bit more to the hardware. As I said, there is a light version of the deep learning plugins in order to accelerate even more the execution, but not only on the weaker hardware, but also on the normal PC. We can use Google Coral chip that already Mr. Beising mentioned about, and it can be used especially in cases when we want to have a real-time predictions. Yes, so this is mostly available the light version, and the Coral support on Linux, on Ubuntu, on Arc of 64, but we're also working to make it possible on Windows. Maybe now I will tell you more about each plugin. So first of all, the image classification we use to inspect materials. And for example, we have one use case where we have coil springs. We want just to determine how many white markings we see on the outer part. In this case, is 5. So the plugin delivers are the label 5. In this case, it's 3. We get the 3, and we have also the corresponding confidence. With this confidence, we can also control our outputs, because with the threshold I will show you shortly in the EyeVision, you can catch predictions that are not so sure because they lie below the confidence threshold. As I mentioned, there is also the heat map feature. For example, we have an example of the material with a crack. We want to determine if there is a crack or not. In this case, we can say that it's positive, but we can also label it as defective. and we can see that the focus was on here to make the prediction, which gives us, as I said already, a weak localization. Object detection application is, as I said, you localize the objects also with the bounding boxes. For example, we can pick a model that detects faces. Then we get an image with the bounding box or the coordinates of the bounding box of the face, and also the corresponding confidence. You can detect multiple different classes of objects like person, car. You can see that you can detect number plates, or before I told you about this application of inspection of the defects, but just by saying if there is a defect or what kind of defect there is. With object detection, you can also get a localization with the bounding box. To the optical character recognition, I think this is clear. You just get pass the image with the text you want to read with a special model, and then, for example, there is a model for reading number plates. Then you will get the text, and you can also get the confidence for each letter, for each character. And also with the confidence threshold, you can control it. There is also a possibility, if you have a text that you know that is more or less the same, that the characters are of the same distance, in the same distance or of the same size, then you use the sliding window approach and you classify the letters. So you get the classification or reading of each character. Exactly. And now when we combine two plugins, for example, in case of number plate reader, we would combine object detection with a special model for license plate detection, and also a license plate reader model. Then we'll get a number plate reader. So I would just show you quickly in the EyeVision. So you can see the EyeVision, and this is how you can build the number plate reader, but it's also available on FOT Wiki, which you can download and test in your in the demo version. First, I will just run the whole project. I will then explain one by one how it works. So you can see that we get the desired output. First of all, we load the image, then we take our object detection plugin from the list of models that we have. We can select one that we want. We can set the confidence threshold. There are two thresholds to give you the warning, but also the objects that are below lower confidence threshold won't be returned, because it might be just not maybe some noise, and this is also how to control some wrong predictions. So, and normally the predictions above the confidence threshold are marked as green, as I showed you, and between the confidence thresholds as yellow to give you the warning. With interpreter control, then you can catch the warnings and maybe decide what you want to do with that. This is also this part shows you this part actually. With this part, you can control the number of detected objects. For example, if you know that there should be only one object and detected, and you set for example here, and you the tolerance that its maximum can be 2 or even 0, that you are sure that it will be 1. Then if it detects more than 1, then it will give you again the warning. Then the mostly here are the the options to just visualize your results even with the label or the confidence. You can see it on the image, and global string. I will show you maybe. So first of all, I will just execute the part of the object detection. You see the object, the label, the confidence, and the bounding box. The bounding box is also can be found in the coordinates in the global string viewer, the class and the bounding box, the confidence and the class, but also in window in the window pickup list. You can see these coordinates, and then these coordinates can be actually passed to the copy region of filter. With this, we extract only this area. We copy it to the image memory 1, because we can see, we can just want to check if it was the right region of interest, and then we apply OCR just to this extracted text. Then we can see the output and the confidence for each character. There's again the possibility to control the control the confidence, so that you can get a warning in case there is some unsure prediction, again like for object detection. Yes, so I will go back to the to my presentation. Yes, so the next use case, the next task or application would be image segmentation. So this is more to specify, to determine more exact shape, not just bounding box, but there's the shape. You can see it here actually on this banana use case, where you have bananas and you see the contour. You can output the contour, and again the label, the confidence, and the corresponding mask. The mask is just for each pixel we give a grayscale value. That means to which class does the, or to which instance of the object does the pixel belongs. So in order to separate each banana, we visualize it with different grayscale values. So but it's also possible to see each object in a separate image memory. So you can extract each instance of the object. Yes, and also with the boxes. Next, how can you can combine actually the deep learning with 3D, and in this use case, for example, we get the mask again of each object, and also with the corresponding depth image, and with the 3D algorithms, we can detect the objects in 3D. Yes, and also by leveraging this grayscale mask, we can also do similar use cases for thermography. And this, for example, this can be used to, when we have already this coordinates, also the Z coordinate, we can take a robot that would pick this up and put somewhere else. So this is this kind of use case. And there's also pose estimation. This is compatible with the Coral chip. So you can do the pose estimation in real time. So basically what it means, it just detects the 70 key points like you see on the image, and for also eyes, the wrists, and also the hips and so on. So you can localize parts of the body. As I mentioned, also there is a tool for making annotations for preparation of the data. So in case of image segmentation, would be just sorting of the of the images into corresponding classes. This is just 2 classes, but you can make as many classes as you want, and just in the end you will get the images in the corresponding subfolders. In case of object detection, you would draw, you would annotate your image with a bounding box. In this case it's license, but you can add also the label. So in case of training, right now we have this possibility to generate a model if a Coral chip is available on Ubuntu or R64. So as I mentioned, actually I can show you a quick video. So basically this is this tool, and what you do is, oh, I think there is an audio to this, but okay. But maybe I will still explain this way. So you take a general pre-trained model, or you have some more like some other model that is more close to your use case. You pick from the list. You also pick your data set that is prepared with the annotation tool, because it requires a special structure. Then, yeah, so for example, this is something that is actually done automatically, but if you want to make sure that the pre-processing was right, because you weren't sure if you didn't add additional image or something like that, then you can force this pre-processing, then it will do once again, but it should be done everything automatically. Then number of iterations. Number of iterations, it means how long will the training last. So for example, the 500 is set because it's a standard, like from experience is the best, because you can already get good results. But if you think that with a longer training you would improve your model, then you can just increase the number of steps or even decrease if the model is already good, and you don't need to train so long. Then you just give the name so that you can find it later in the list. And icon is actually something that you add so that then in the list you can find your model, because it shows you like more or less what it is about. Is better because it's more visual. And then you but you can also just set the default icon, that is if you don't want to do this. And then you can just click on train. And okay, I'm explaining the icon again. So, and then you just have to save all your programs, because in order to have as like because this is also a powerful thing, so it requires for all programs to be closed. And then we do quick data processing, and training is in progress. Normally it depends on, because it uses transfer learning, and I said it's based on the pre-trained model, then it's quicker. It might even takes a few seconds to a few minutes, depending on the size of your data set. So the bigger the data set is, the longer this will take. And then you will get the information if the training was successful. If not, then you just have to check the log file, but normally it should be successful, of course. And at the end, you can just check if your model can be found in the corresponding image classification plugin. So you just can drag it and drop, and you see this is the model that you, because you named it filament inspection, so you just pick it, and you know that it's that it was successful, because you can see it here. What I said about icon is just, if you want to make these models distinct, from each other, then you just upload your some like customized icon, and then you have, for example, I don't know, some small icon of filament or some defect detection, something like that. It's just for visualization. Yeah, exactly. And this is the end. Exactly. So this is for image classifiers, was what I showed. And one more thing. So this is actually something that was already mentioned. So basically, to somehow accelerate, reduce the effort while preparing data and doing the training, then the tools like blob detection that we already have, or we have also a tool called Homogeneity Inspection. This might detect already some defects, and this can be used as input for our training, so that the data is like faster, data preparation and annotation is faster. So that's maybe but this is something that we're also working on to make it like a more user friendly. So actually that's the end of my presentation. You can find some example projects on FOT Wiki, and yes, in case you have any questions, then please ask.
Maybe you can run one or two of the demo projects.
Which one?
Whatever you have. Maybe the one with the bit picking also was the combination of 2D and 3D.
This one. Yes. Yes. So this is actually what I already mentioned, to find the shapes of the objects, and then with the depth images, we can also estimate the z coordinates, not only x and epsilon like here in the 2D image, and then we can see the objects in 3D. There's also another example. So this is so for example, here on the palette you have a bag, or I don't know how it's called, but like kind of bag, and you can see the that it was found, the shape, the mask, and then with the 3D algorithms you can see the you can see this in 3D. Yes. So this is it okay, this project, or?
Yes, maybe you can explain a little bit. Or if everybody can download it and can have a look by himself how it works, it's also okay.
This will be available. Yes, this will be, yes. But the other project, like with object detection and classification and OCR, then you can find on the wiki. So then you can download also this. Yeah.
Yes. So.
Stop sharing. Yes.
Yes. So I think we have a nice overview about our deep learning stuff. I hope it was somewhat interesting. If there are any further questions, simply feel free to ask now. Or the other option is, of course, you can send always a question to our support at evt-web.com. And we will answer you very fast. For example, also if you say, okay, I have these gearbox, or I have these connectors or whatever, and how can I train it, or what it would be a good pre-trained network which fits to it. Of course, we have some networks which we have trained for customers, so we could add training to these networks if they fit very well to different needs. So simply send us one or two images of the parts you want to detect, or and we can give you an idea what would be the fastest and best way. Okay, so if there are no other questions, I would say thank you for the moment. And of course, you have all the details. Write us. I can really recommend download all the project files so that you can run it on your own PC. Then you can see how it works. And looking forward to see you again. And thank you very much.